Hello. I wanted to make this short documentary on Star Slice, an application I made over the last few months that creates random star fields. You can go to those star fields and look at planets. And really, I just want to talk about uh, the short history of this project, the decisions I made, and the reasons for those decisions, and all the problems I faced, and this, that, and the rest of it. So, without further ado, uh, let's get into it. So, uh, the origin of this project is in Spelljammer. Some of the D&D books came out, and I thought, how cool would it be if I made this like randomly generated star field, and then you could screenshot it, and you could use it as a map for a campaign. That was the original idea. So with that idea, there comes a lot of detail. So one, make stars, and I am so bad at handwriting. Geez, I should see a doctor or something. But two, with the stars, you have planets. Not much of a campaign setting without somewhere to land. And, well, you don't need to land on planets, I guess, is what I could tell myself, but I guess we account for that too. So make planets, and then those planets, because to be realistic, make moons for those planets, and then it wouldn't be very realistic if we only had stars, planets, and moons. So we have debris, like asteroids and rogue planets. I guess gas clouds, what have you. So already we have a lot of stuff. And what I wanted, or at least what I envisioned, is the map would be something like this. You would have your screen, and then each star would be like a diamond. And then you could click on that diamond, and on click, represented by my great art, you would see its like stats. But what's more is I didn't want this to be like a Mass Effect, where you can go to the star system. You can see the universe, or the galaxy rather. You see your stars, and then you can go to I forget what they're called. You can go to a particular star, let's say, and then once you go to that star, you have planets, and you can see their orbits around their beautiful their stars. But really, that's like this top-down view, which not quite top-down. It's at an angle, but still, like you have this unchangeable view. But what I wanted was you to be able to right-click this map and kind of like press and hold and then rotate. So then eventually you would have this flat view where the stars would appear like diamonds as before, but they would all kind of be on top of each other, blah, blah, blah. So already we have a few like key concepts here that are interesting. The first being stars don't behave like this. Stars aren't like maybe in the grand cosmic scale of the universe, where everything is so big. Like a galaxy like our own appears like a spiral. So we can see this image, and it's two-dimensional. Yeah, of course we see it. So relatively speaking, the width of the galaxy, it's much greater than its height, let's say. So already we have a sort of like scaling problem. while this isn't quite accurate, as there would be stars down here, stars above, the first concept was like this. It was this long sort of prism that the stars would be generated in. And I found that that wasn't really the best. It could have worked, and it can work, but what I decided on doing was making a sort of cube for these stars, just because it was sort of easier. So I'm sort of getting lost in the process. So hopefully I can rein in a little bit. So the idea, or what we have so far, is plane of stars. And my drawing pad is giving me a lot of trouble today. But so we have a field of stars, and no matter how far you zoom in or out, they'll always kind of be the same size on your screen. So it's like at the very beginning, I wanted scalable UI. I'm no longer going to try to write things. By God. Anyway, so we have a sort of cube. So first we should probably give this cube sort of dimensions. So it's like this is, again, foundational for what this application does. Like I wanted user input. Here I am breaking the promise I made. User will input number of stars they want. And then how dense do you want this to be? Like how big or how close do you want these stars to be together? So this, again, presents a very... it gets complicated very quickly. It's like density. Like, what do you mean? Like, okay, density. So there are dimensions in this, but what are the dimensions going to be? And so what I kind of researched was like how dense, for instance, is our arm of the Milky Way as far as stars. So like what I found was there are approximately 0.003 stars per cubic light year. And if you're like me, you'll say, wow, that is not very dense at all. And then it's like, well, space is called space for a reason, as I have to remind myself. So with this number of stars and this density, which I finally decided it should have a range of 0.001 stars per cubic light year to 0.005, which is funny because it's like, wow, that's pretty dense, even though it's such a small number. But anyway, so with those two numbers, density and number of stars, we have the dimensions. So based on those two things, the cube now has a sort of, well, cubic area that it can cover, or cubic meters that it can cover, to be precise. So here the cube is now made of smaller cubes, let's say, and those are each 1 cubic light year. So the meters, quote unquote, in Unity, a distance of 1 is 1 meter. So now a meter is a cubic light year. But we'll soon discover that that is, well, maybe not leading to problems, but certainly having some interesting consequences. All right, so finally we have a cube. To put everything in. How nice. The problem being well, what are we going to put in this thing? Well, obviously, it's star slice, so the star slice generator should make stars. Pretty important. So this kind of, again, like how you have a plan. I had a plan, as discussed. Like these stars were just going to be points, what have you. But I was like, you know what? Like just to test things out, I didn't want to go into, like in my mind, I was going to have to go into Krita, like I am now, and then make a diamond that I liked, and then import that diamond into Unity, and then use that. But so I was like, okay, for now that sounds like a lot of work. So what I'll do is I'll just make the star prefab a ball. They're going to be this three-dimensional spheres. So this part is easy enough. Literally, the star generator script, and this is our first foyer into actually like using C# to do what we want. So, really, it's funny because when I was doing this project, I thought a lot, or I still think it's like, man, I really didn't do a lot of planning. But the funny part is, like, now that I'm going through the thought process, like, no, I planned a lot. But it's funny that some things, just the things that you do influence your plans. So in this case, again, I used a ball as a star prefab, and then I thought, what if I just made the stars spheres in general? But I'm getting ahead of myself. So the stars, which are now balls, they spawn at some point in 3D space. Well, now what? Certainly the stars have variables associated with them, and this is another thing I planned for. It's like, what are stars made of? Well, hydrogen, helium, and iron, and blah blah. Well, carbon, blah 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 blah. But no one cares about that. So what I cared about really was a few things. One, type. So there are 7 types of main sequence stars, and those are the only ones that are featured in this application. It's like you could, and the reason for that is because, one, I would consider like black holes, white dwarfs, and the like as debris, like just random stuff that you just find. And I never really got to that part of the vision, for better or for worse. And there are, of course, like super giant stars that are not main sequence, and that they just take up so much space. So again, we have scale here. These stars, which were supposed to be diamonds and cubes, they are now spheres. And then with that idea came, okay, these spheres should be represented or like a representation of our sun. So it's like if a star is 15 times larger than the sun, then it should appear in this sphere with a radius of 15 times a radius of 15. So so this is the first time like the question of scale kind of like comes up. I assume like my pen battery is dying, so that's why it's freaking out. But we have the units of these stars are now dependent on on the sun. So it's like 1 meter of star is 1 sun radius. But like I said before, the 1 meter in Unity is now a cubic light year. So we have we have this 3-dimensional space representing 2 different things, which is cool. But it's gonna lead to some problems down the line. But again, I'm getting ahead of myself. So one type. There are 7 types, if I remember right. Type O, B, A, F, G, K, and M. Our sun, for instance, is a type G star. So again, those are the only things we're going to be working with. So with that comes like, okay, well, each type has like their types for a reason. They have identifying elements to them. So 2, stats. So once a star is generated, we have a script that attached to the star that gives us this type. Then we have multiple scripts, something that I rectified later with planets. We have many different scripts giving it stats. So we have a script that gives us the star's radius, then its density, its mass, its luminosity, its temperature. And while I did do my best to be like pseudo accurate, there were definitely like corners I had to cut. For instance, with like density of stars, like stars do not have the same density. I guess that goes without saying. But even within types, there are subtypes. And those subtypes have different densities from one another. So what I decided to do was, rather than just randomly like making, or rather than just making it more complicated and randomly generating a subtype for a type, and then from that subtype generating a range of, or generating a density from a range of possible densities, we'll just pick one, what I deemed from Wikipedia, pick one density from the range of possible densities of that type. So this spectrum of types, let's say, in their spectrum of densities, we're going to pick one from the middle. It's not accurate, but it's what I did. So, and from that, of course, like the mass, you get like temperature and luminosity and what have you. So now we have stars inside a cube, but now these stars have stats and types. Awesome. And I wish I could show you how positively dismal this scene was. It was literally just a bunch of gray balls floating in space. Wow. Pretty cool stuff. So with these gray balls floating in space, I thought, wow, wouldn't it be cool if they had color? Obviously, there are different types of, or different colors of stars, so I wrote a script. Well, first I did research, like how is the star's color affected by its mass, temperature? So, like, type O stars, for instance, are going to be brighter than type M stars. The younger the star, the brighter it is. The brighter the star, the more quickly it dies, and that is just a general rule, but it doesn't really matter, I guess, here. But anyway, so with brighter stars, they burn hotter, and so more energy, let's say, goes into these photons, and these photons, the more energy they have, the faster, or sorry, the more energy they have, let's say, the higher their like frequency, let's say. So, as we all know from our physics classes, light is a wave. So, let's say this is low energy. And then, so what is high energy? Well, high energy would have to be something with a shorter wavelength. So I am not looking at the math that I did for this, but what the idea, right, is like you have the range of visible light, which is about 380 nanometers to about 700 nanometers. So we have low energy stars, type M, and sorry, oops, let's see, that's a trick that I constantly fall for. You have high energy stars, type O on this end, and then low energy on this end. I've made that mistake so many times in the process of like you would just my brain is used to high energy meaning bigger number, but that is not the case here. So it goes without saying that light emitted by stars is not purely visible, but that does really matter here. So we have, these type of stars, let's say O and M down here. So with their temperature, you'll produce a type of wave represented here, or wavelength represented by lambda. And this lambda, which has units of nanometers, is fed into a script that gives the RGB of whatever this is. So it goes from like HSV hue saturation value, I believe, to RGB red, blue, green. And so this is represented like in Unity and well, Krita, now that I'm looking at it, as a wheel, this color wheel. So we have red down here. Sorry that this is kind of dumb because I'm using black and white, but red down here, and around here you have violet. So what this this does, and this is such a funny thing to do, you have this wavelength turned into like a degree value, I should say, from 0 to 270, and so wavelength put through a script that gives you this degree value, and that degree value gives you your color. So now stars are not just gray blobs floating in space; they have color now. So step 2 was, now that like I'm kind of committed to using these spheres, is these don't look like spheres at all. They look like, I don't know, the like pit balls you would find at a Chuck E. Cheese or something. So it's like, okay, well, if they're going to be stars, they should probably glow, right? And so this was my foray into post effects. And let me tell you, it was fun and not nearly as complicated as I thought it was going to be. It was a lot of trial and error. Like some things I forgot, like you have to have like an object in Unity, you have to have an object in the scene that has post effects, and like just setting it all up. I can't really explain it too well because I honestly can't remember. Because once I had it down, I literally just forgot about it. But that object now like floats between scenes, just rendering the light for things, and it was fun messing with the settings, like how bright the light is, like how far the rays, quote unquote, extend outward. So it was a lot of fun to work with, and I'm glad I did it. And honestly, it works great. It looks great, or at least I shouldn't use great. I should say it looks better than plastic balls floating in space. So we have, now colorful balls floating in space that emit light. So now with the fun part over, we enter the terrible, terrible world of UI. These stats have to go somewhere, right? So with the original idea of diamonds floating in space, these diamonds were going to scale with your view. So if you were, let's say, very far away from the galaxy, you would see all these stars, stacked on top of one another, in such a way that it would look kind of like a mess. But if you were close, they would still be the same size, but obviously represented in this map sort of format. There is like a kind of problem with this. It is kind of hard to tell then like what stars are beneath what, and I guess your only way to tell that was, well, would have been if, like, one star just, diamond covered up another star's diamond. So, even though none of that matters, like, the idea remains. UI should scale. Oop. Perfect. Awesome. So scale with what? In this example, it's a scale with distance from, like, user distance from star. But now it's several things. It's more like it scales with the star's radius, which makes sense. Like, the star should feel the exact same, or should look the exact same regardless of its size. So with that concept, though, there comes a lot of, like, problems. So one, the user has to be able to get to the star. So I created like a cursor. I went into Krita and made a small cursor. It's literally just a circle. So now the user can click on a star and then literally zoom to it, which is awesome. But when does the user stop? Surely it cannot be when the user gets to the star's position, because then the user would see the inside of the star, and it is just a hollow sphere with it would be your inside of a sphere that glows, essentially. So the user has to stop, like, let's say 3.5 radii away. So this required some complication. I had to learn, like, I guess, raycasting. So to my understanding, this is what Unity does. The user, represented here by this oval, or rather the cursor, shoots out a ray, and if it hits a star, then user moves to this direction. Like, after, of course, it hits a star, then the star, like, then it says, okay, object, do you have a radius? And the star says, yes, of course. This is what it is. And then it's like, okay, we will go to 3 radii away from you, and then we'll stop. We cannot get closer. Now, there's some issues with this. Like, sometimes it does get closer, and I don't know why. Maybe it has something to do with just how Unity deals with speed. Maybe Unity doesn't like to stop an object abruptly. I really do not know what the issue is here, but that is just a known bug, let's say. But anyway, so once the user is 3.5 radii away, then the star lights up. Well, not in the traditional sense, but now we have text appear on either side of the star, and that tells us, like, what kind of star it is, how big it is, what's its mass, like radius, what its temperature is. Sorry, now that I'm thinking of it, I forgot to mention that with wavelength, it's like there would be experienced. Well, upon thinking about it for 2 seconds, you would realize that, well, shouldn't green be included in those colors? And there are no green stars. Well, the answer to that is technically yes, there are, but our eyes perceive light in such a way. So our sun, should be green, but because the way our eyes process light, it appears as yellow, or rather this white sphere of glowing death. But that is just another oversight. Well, I shouldn't say oversight. That is just something I realized and then just decided not to care about, because, hell yeah, green stars. Why wouldn't you want to see that? It gives variety. But anyway, sorry, back to the problem at hand. Now we have statistics that appear to you. And that was kind of annoying, because then it's like, okay, well, surely these stats can't just appear as a wall and be unchanging, because what if the user approached at, like, I don't know, a 90-degree angle, and now the stats are just like a black line. So the UI now has to change with the user. So it's like if the user moves around the star, the UI has to like stay facing you. So that is pretty, I would streamlined. It's something that we do in video games, and nowadays, well, video games application is just like offhand because it's sleek. So I had to write a script for that. By write, I mean copy off of. All right, so with star names in mind, we finally have stars that exist with stats. Oops. In a cube. So we have a star map, and then now we can say we are done. Screw that. And so this is where I should have said either one of two things. One, fuck this project, I'm done working on it. Or two, now we work on planets. But I guess that is technically what I did say. I did say let's go work on planets, but there's a problem. Where do these objects go? Where do the stars go when they're not loaded? How does Unity know what to do with them? And that's the answer is it doesn't. Unity will destroy the stars if you leave the scene. So it's like, okay, now we have a problem. So if we want to go to these star systems, we're going to have to create a new scene that's destroying all the stars. So now we need to save them. So it was literally by force that I had to create this save system that was not part of the original plan. And let me tell you, the save system sucks. It was by far where I spent the plurality of my time. So what the save system does is, user says, I want to save this star field that I've created. And it says, okay, well, what's the name of this star field? Let's call it map 1 or whatever. It's like, okay, so we'll create a folder, and well, first, like what the script does, it checks if that folder exists. So if the folder exists, then it goes forth. If it does exist, it creates the folder, and so either way, it goes into the folder, and then it'll for each star, it gets that star's name. It gets the rest of its stats, its position in space, and then along with this, it gets the player's position and rotation in space. So with this data, it then puts it into a JSON file. And so that JSON file contains all of the stars, like statistics, and names these files accordingly. So just according to the name. So in map 1 folder, you will have every single star named, and then you can click on the file, and then you'll see the star name and the rest of its stats. Okay, perfect. Again, easier said than done. That was such a difficult process to complete. But once it was done, it's cool because now we don't need to take screenshots. Now we can take the map 1 folder and then send it to all of our friends, assuming we had any. Jesus Christ, I don't think I deserve friends because I can't fucking type. But anyway. Right. This is all falling apart. Anyway, so we send the folder to our friends, and now the friends can put it in their star map folder, and then they can view it, and we can all have it open while experiencing D&D or what have you, and dope! Aren't we glad that we went through all this trouble to create these folders and save everything? Blah, 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 blah. Okay, so now we have stars with stats in a cube that can be saved. Awesome. But now that has another problem. So it's like, okay, we can save them. Awesome, that works. How do we load stars? And by golly, if this also wasn't a real pain. So what the loading script does is it goes into the map1 folder, or whatever it is called. It takes every star and then it creates a star. It generates a star. Like not this star, but a star. It goes straight from the like star prefab. It is brand spanking new. So what you may ask is, Jake, isn't that a weird idea? Because if you put a star where the star should be, isn't it going to just create its own stats? It's going to be just randomly generating its own stuff. It's going to have its own name. It's going to have its own type and mass and what have you. And the answer is yes. That's exactly what happens. But well, I don't want to call it genius because it's really a stupid idea. So understanding, oh man, now I have to go into the order of execution in scripts, and there's a better way to do this. Anyway, so what I did was there's an invoke method in Unity, and so you say invoke this script. It could be running the star's mass, or getting the star's mass, its temperature, blah 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 blah. And then you say invoke it after 0.05 seconds. Perfect. So this way, oh, I shouldn't say script. I should say function or method. So this is dreadfully boring and dreadfully stupid, I should say. But so we have different functions that do different things. Like the functions are just like the parts of scripts that do what you want them to do. So in this case, we have lots of different functions inside of scripts. So we have a function that gives us type, and then from that type we get mass. Sorry, that's not right. We get radius. And from radius and density, we get mass, because you kind of need those things. And from the rest of those, we can get like luminosity, temperature, what have you. But there's an order of execution. So what this does is it allows the star to run its own script, but between 0.05 seconds of the first, let's say, type, like between the star runs for 0.05 seconds, sorry, I'm doing a terrible job of explaining this, but 0.05 seconds passes, type is called, let's say, and then after 0.0, let's say 0.1 seconds, radius and density are called. So what this does, and this is so foolish, it says, okay, we'll let you run your type, but then after 0.06 seconds, we're gonna put the star that you're supposed to be, we're gonna take its type and then just introduce it to yours. We literally change that type variable in that script. So if you're type M, who cares? You are now type B, let's say. And it's like, okay, well, what about radius? Well, we do the same thing. In between 0.1 seconds, 0.15 seconds, we say, let's say at 0.12 seconds, we say you're going to have this new radius, you're going to have this new density. And so from there, you get mass and you get temperature, and everything is hunky-dory from then on, because it's no longer random. So that is why, and I'll show this eventually when we actually get into using the app, the stars all appear to be the exact same for a few frames, and then they all change to what they're supposed to be when you load a actual star file. Alright, so now we have stars with stats in a cube that can be saved and loaded. And now going back to the reason we went through all that trouble, now we can make planets. So this presents its own set of issues, to no one's surprise. So when I was trying to spice up the main menu interface of this app, trying to create what you saw, which is a mock model of the solar system, I came across a photo, and that photo was, the sun, and from the sun you had Mercury, Venus, Earth, and Mars, Uranus, Neptune, Jupiter, and not Pluto. I'm sure I'm missing one somewhere in there. Saturn, there we go. But anyway, so these were obviously close together. So then under the photo was the magical words logarithmic scale. Fascinating, I said to myself. What a great way to introduce planets into a solar system. Because, as we all know, if the Earth were the size of a marble, the sun would be 7 miles away. These things cannot be represented in a clean interface without using something like this. So, perfect, I said to myself. We will spawn a star, or we'll take that star and literally just make that object unkillable. There is the very nice do not destroy I guess method in Unity. So literally says like we mentioned in general, or you had everything to do with this. Unity will destroy objects that are not rendered in the next scene, but you can override that by just literally typing do not destroy, or do not destroy on load function, like this object. So when a new scene is loaded, the object will not be destroyed. And so we have a script when we go to the system that tells it to do one of two things. One, do not destroy the camera, and do not destroy the star. Also do not destroy an empty an invisible object called main menu that holds a lot of data like what the star map is called, and that's more just saving and loading stuff, and UI is the devil. But all that aside, now we're at the star and we need to make planets. So it's this is my grand idea. Okay, we have planets, right? And the planets, let's say, for instance, they have a spawn distance of either something similar to Mercury all the way out to something like Pluto. So then we'll take this distance and we will spawn a planet and make it, we'll take the distance, make it a logarithmic, so it becomes much, much smaller. In my case, I multiplied it by a scalar because the planets were spawning on top of each other. So to spread them out a little bit, I multiplied them by, I believe, 100. So we have a first distance, run it through a logarithm, and multiply it by 100, so they're spread out, and that's how we get the distance between star and planet. But now we have another problem because the star is still scaled with the sun. So planets tended to either be inside the star or, like I said, on top of each other. Okay, so it's like, okay, clearly this minimum distance from Mercury can't apply because now it's like you have to take it in the star's radius. So let's say, again, let's say 3.5 radius. That's the minimum distance. And so now we have such a clear understanding of how weird this plus star system view is, because we have the star, which size is related to the sun, and now it's not just one. Now I should explain this. So, what in starfield view, 1 meter was both 1 light year and 1 solar radius. But now 1 meter is 1 Earth. Oh, I messed that up. 1 Earth radius. So we have something that deals with literally the distance of the star, or like planet from the star, and having to relate that to how big the star is. So, and then with the planet's actual size, it is in relation to the Earth. So if that's confusing, I apologize, but that's because it is. It's just a weird thing to do. But it's all in the name of being able to see planets and actually be able to travel between them without breaking things. So, like I said, the problems arose, and I kept trying to fix them. Like, okay, this planets are spawning inside the star. We have to make sure they can only spawn at a minimum distance, some minimum distance away, and some maximum distance away. Like, okay, so multiply by scalar, that distance by scalar, so that way they're spread out and the planets are not on top of each other. Okay, great. But now we have another problem, because I want the planets to move. And as we all know, the Earth takes about a year to move once around the star, our sun. So with this, it's funny to kind of see, because initially planets would move, and they would move very, 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 very fast, like dozens, if not hundreds of times a second around this star. And clearly that's not supposed to happen. So let's kind of like bump this sort of minimum distance up. That way the time it takes the planet to orbit around the star is longer. But still, like, I couldn't quite get it right. Like, the way these things worked was like, the logarithm had like some sort of maximum value, and I forget what it was. But once you reach that threshold, I think it was about 10 to the 36. And somewhere around there. So once you reach that threshold, then Unity has no idea what the hell you're talking about. 10 to the 37 ish, you say, that number is infinity. And if it's infinity, then these planets can't move. They're infinitely far away, and so they're not really orbiting. They're standing still. It's like, okay, well, that sucks. So it's like we have this weird problem where either the planets are too close and they keep moving around very, very quickly, but we fix that by bumping up the distance. Now we have this problem where there's a maximum distance that it can have be far away from the maximum distance from between planet and star, and before Unity just freaks out. So what I thought of, like, why go from this step, which is make minimum distance, make max distance, pick one in between. Why would I do that when I can just make a period? So it's like, we already know that the planet will rotate, I don't know, let's say once. Let's say it'll rotate around the star once every 5 seconds in real time. Or it can rotate once every 500 seconds in real time. So picking this range, we can reverse engineer. So it's like, now we have period, and because of that period, we now have its distance from the star. And so by doing this, we have designed it not to fail. Absolutely amazing. Good job, Jake. We did it. So now that we have planets orbiting their stars, we have another thing to deal with. So it's like, okay, we can go to stars, right? We can click on a star and just move toward it. So what about planets? But it's like, oh, well, planets are kind of moving, so that makes them harder targets to click, and it would be kind of annoying if you literally just followed a planet around with your cursor just to get it to work. So it's like, okay, obviously that can't work. So here's the new hotness. We'll have a star. We'll have a star at the center of its system. And we'll have its planets, orbiting around. And then let's say in the bottom left corner, there'll be UI, our favorite. UI that will have a field, or sorry, a kind of scroll wheel, I forget what they're called, but so it's just a list of the planet names. So you can click on a planet's name, and then you can go to it. You can go to that planet. So this is the annoying part. I wanted to have it. Okay, so like with stars, you go to the star, and then there's star name, and then its stats, and then there's a go to system button that you can click on. So it's like, okay, but you're still just facing the star. And of course, like, you can move the camera this way and that. But it'd be kind of boring, right? If you had the exact same thing with planets. So I thought, wouldn't it be cool if you got this view? You have a planet. That you're trying to go to, and then you have the star at the center. So you have this cool view of the planet literally moving around the star. And in the top right corner, let's say we'll have planet name and stats, what have you. Okay, this is a genuine problem. So, but first, I will explain why I'm a genius. So, I'm not sure if this actually would have happened, so I shouldn't say I'm a genius. But my first thought, right, was like, okay, we're going to have the camera. Let's say, I don't know, camera. It's going to have to take, like, the planet is moving. Like, we're not going to stop time just so the user can examine the planet or whatever. So the planet's going to have to take the position of the planet it's visiting. So it's like, this is where things get. This is what I assumed was going to happen. So, planet moves. Then, camera takes planet position. Then, planet moves again. Then, camera takes planet position. And so on and so forth until time immemorial. So, wait, I used that wrong. Anyway, so there's the update function in Unity, and that's like, it literally happens every frame. So it's handy if for movement, but if an object is getting another object's movement, I assumed it was going to happen because I saw it in some like AI code I was looking at, that there's like this stuttering effect. So literally the planet, it's so hard to draw, but just imagining that like the planet moves and then the camera moves, and it's this constant sort of like warbling sort of thing because the camera's trying to keep up. So what I decided was, instead of writing code that would behave like this, I was like, okay, well, I could just make the camera a child. Child of planet. Now, this was kind of annoying to work with, but it was ultimately the right decision, I believe, because a child will always inherit its planet, its parents' rotation and position. So now there's no extra code required. The camera is a child of the planet, and now it just moves with the planet. Which, perfect, awesome, that works. Now comes the real trouble. So the real trouble being, how do we actually do this? It's so annoying to work with because there are functions like look at that tell an object to look at another object, and then there's look rotation, which does something similar, and I'm sure someone smarter than me could tell you the intricacies of how these things work, but I had to actually sit down and think about this, and I had to get away from a computer and actually go back to my undergrad days of working with vectors and what have you. So there are a few things that I had to really think about, and it's simple. After you do so, well, simple, quote unquote, because now that I'm remembering the math, it's almost hellish. So we have this, the star, and then we have planets orbiting it, and this is on a two-dimensional plane, let's say, ish, pretty much, and it is y direction, then x direction, exactly what you would see on a Cartesian coordinate system. Alright, so now, because of this view, the ideal view, where planet is down here in the bottom left, and we have the star. So now we're dealing with something like this, where up is actually the z direction. So now we have this interesting sort of relationship, which is hard to figure out. It's hard to visualize in this two-dimensional space, but I'll do my best. So we have star, we have Mother of God, planet, and then we have camera. So we have, let's say, this distance, which is, let's say, distance between star, planet. We have this distance, which is tricky. We'll say distance between planet camera, but we also know that there is this distance between the center of the planet and the camera, like a different sort of distance. So this is difficult to explain, and I could show you the code, but it's obviously also pretty complicated. Maybe I will do that. Actually, you know what? Why not? Alright, so upon further review, I've realized that what I drew wasn't inaccurate, and it's not useless, but it's not what I actually did. But because what I did was kind of clever now that I'm looking at it. So, what I said was we need to keep in mind three things. We need to know the star's position, the planet's position, and then the camera's position, or where we want to place the camera. Well, the cool part is we already know the star's position. The star's position in this system is already 0, 0, 0, like it is at origin. So what we can do is we can just create a new vector that has these coordinates, the planet's position and the planet's positions, like x and y coordinates, because it is on that xy plane. And then we just make a vector, and a vector is, think of it as a line between 2 points. In this case, it's a point between the origin and the planet. So we create this line, this vector, and then we normalize it. It's like, and normalization is just you create that vector. You still have its you still have the lines like rotation, let's say, like you still have its direction, but now its magnitude is now 1. So if we think back to, I don't know, Despicable Me, we have vector because he has direction and magnitude. So a vector, or this particular vector, now has a magnitude of 1, but still the same direction. So after that, we need, according to the drawing, again, not totally inaccurate, we need to take that direction and then make another sort of vector like that is perpendicular to it, and that's like the up direction, let's say. Up in this case is -z. So we have the vector, the first vector, and then we have a second vector perpendicular to it, which is now normalized, and then multiplied by this scale, this 1.5 times radius of the planet that we're on. And now we combine these two vectors. So it's like, okay, well, what about that sort of like skew? Like, let's say the distance between the camera and the planet. So that offsets, that makes the planet like in the lower left corner and the camera in the the center. Well, that doesn't need anything other than the planet's radius, which is described here. So it's like we combine these vectors. And then we just take the x component and make that the x position. Then we take the y component, make that the y position of the camera, and then, like I said, you don't really need to know anything other than the radius of the planet to have the z component, the up. Well, in this case, we're going -z, but the up direction. And then what's clever about this is like, okay, well, we have this, but wouldn't this put this, I don't know, inside the star because it's so small? It's like, yes, it absolutely would. But because we don't set the camera position to that until after we make the planet the camera's parent. So now the camera's origin, it's 0, 0, 0 is the center of the planet. So now with these normalized and planetarily scaled vectors, we have a new position for the camera to go in. And then we just tell it to look at the star. And this vector 3 back is telling the camera what direction is up. So in this case, up is negative z, like I believe is what this means. So with that, I believe that was the final, well, not the final hurdle, but certainly the last major, like, I guess, coding achievement, let's say. All right, so now we can have that cool thing of seeing the planet and this, like, as it rotates around its star, we have the planet's view of things, and that is absolutely cool. But there's still one more problem that I haven't really mentioned, and it's because it's incredibly unexciting. So the problem was similar to the UI in the main menu, we have the star, and then we have these planets. And these planets each have names, and these names appear kind of above them. So it's like no matter how they face, like they always rotate toward the camera, similar to, well, actually the exact same. They shared the exact same code as the star UI. So the problem was when you would go to a planet, of course we have this scene view of planet, star, and then we'd be able to see the other planets in the distance, but their names would no longer be on top. Instead, they would be cockeyed like this, and I couldn't for the life of me, and I literally spent I don't know how many hours trying to figure this out. I tried different things like changing the direction of up. As far as the look rotation is concerned, I tried doing things with because it's like, okay, well, obviously the problem arises because I'm changing the camera's position. Like, I'm now making it a child of something, so that must be the problem. And so I kept bug fixing, trying different things, and after an amount of time, I realized that it's like, no matter what I do, this behavior does not change. It's always like this. Sometimes I could get it so that's a little bit wonky, like it would appear on this side over here, but then a planet on this side would have it still over here, and so it was kind of funny to watch, like, as these planets like kind of like swerve around to see their names kind of like rotate, and you have that brief glimmer of hope where it's like, okay, now it's going to set itself straight, but then it just keeps rotating to the other side, and it's certainly frustrating, and I couldn't figure it out. But again, it seems like, no matter what I do, this problem persists, and that should have told me something right away, which is there's a script that is overriding what you're doing. And the script was actually the main script. it was the script that I've been using all along. It had this one line of code that was forward. And this, again, like, this is the direction. Like, it makes sense for this to be here. The direction that the camera should face, sorry, the UI should face, is between it and camera. Okay, so because Unity is weird, and so, like, you have this 3D coordinate system where you have forward, back, then you have left, right, up, down, or something like that. So you change forward, and now you change what up is. So because of this line of code, forward became between whatever the UI and the camera is, and so up is now this left direction. So that's why I was seeing the planet names rotate 90 degrees. So what I did was I literally just deleted that line of code, and it works famously now. And so with that, I decided that is the last bug I should fix, quote unquote. So with everything in mind, that I decided to build it, and there were a few problems, namely the star and planets, they didn't show up when you actually went to the system, and that was a rendering issue. I set the, I guess, camera's rendering setting too low, and so I just bumped it up and rebuilt, and it worked fine. Except the planets didn't show up either. Not just the planets, but their UI didn't show up. I'm like, okay, well that's strange, and it turns out that's because how something works in Unity, that is not how that thing works in Windows or Mac or whatever. So what ended up happening, because how the code was written in Unity, it would the planets would have a period, and that their period orbiting around the star, that was of course inversely proportional to how far they were away from their star. So when there is no distance, let's say if the planet doesn't exist, it would divide by 0 and the universe would explode for a few frames, and then the code would kick in, the invoke methods would start running, and then boom, everything's fine. You have planets that are at a finite distance away, and nothing explodes. However, in the build, those brief few frames of infinity are enough to get everything to just stop working. So the invoke functions never run. So that's why the planets were rendering. So I had to go in and tweak a few things, try to stagger the code in such a way that infinities weren't produced, and that was annoying but understandable. But without further ado, I've talked on long enough, so let's actually use this thing however briefly. So the default settings are 100 stars with the density of that of the Milky Way, or at least our arm of it, and we'll make a map. Awesome. So we can back up, look around, see what's what. Let's go to this purple one. Ibuit. Awesome. So let's go to system. That won't work because we have to make a name first. Let's say, let's call it map 1. Awesome. So let's save map to file, and then before actually going to the system, let's go to the main menu, and then load map. We can see me making fun of my friends, and then map 1. Boom. You see all the stars that there are bright flashes, and then they actually turn into what they're supposed to be. But we should be around a star. Oh my gosh, are we not? Oh, that's interesting behavior. Huh, I wonder why that is. Oh well, it's no longer my problem. That's what I like to say. But anyway, so let's go to system. Oh, this planet doesn't have any stars. We can go back to star map, experience the same problem, but it's all I could think of. 5 ms. I wonder what god that is. Alright, awesome. Electo. Let's go to it, and now we can see the star, or this planet revolve around the star, and now we can see a Philomulus off in the distance revolving as well. So it's been an incredibly long process. That is pretty much all there is. A few takeaways. One, I would say from the next project, I hope to stick to my vision. This was supposed to be a lot simpler, and ended up turning complicated. But don't get me wrong, I learned a lot, and I'm glad I did it. But it did take a lot of time, so I should be more mindful of if I have an idea, something to change, I should consider how much time it'll take. First and foremost. The second thing I would like to be more mindful of in the future is just like the code that I use. Like I said, I don't really have a problem ripping off publicly available code, especially when it's just like short Unity tutorials that tell you, it's like, hey, if you want UI to face things, this is how you do it. But I would say I should completely understand exactly what code does, and for the most part I did with the UI facing script. But again, that one line of code that changed forward, I didn't consider that. And because of that, I ended up just chasing my tail for hours, just trying to figure out what was wrong. And all I had to do was delete that line of code. So in the future, I'll have to be a lot more mindful and attentive to stuff like that. But it was a great experience. I'm glad I did it. And I guess I should thank my friends who let me rant about this, let me show them my progress, and all of the kind words and support that they showed. And to all the nameless doctors who let me use their data. And this is pretty long, so let me just conclude with thank you for watching, and have a good one.